Hello and welcome to the E-Mobility Innovation Podcast, the podcast on e-mobility for research and industry. My name is Simon Voss, and in the coming episodes I'm delighted to provide insights on discussions I had with leading experts on the field of e-mobility at the E-Mobility Production Days hosted by PEM of RWTH Aachen. What's the status of innovation and where are we headed? Let's find out. What are the big fields that we have to work on fuel cells in order to industrialize the whole manufacturing of and industrialization of the fuel cell?
We have figured out during the last couple of years as a supplier for assembly and test technology that we are facing a lot of challenges to make a fuel cell mature for production, for serial mass production. There are, to be honest, a couple of things to be resolved to get this done in regard of optimizing the product with the design and the choosing of the materials you're using. Because a lot of materials which are taken nowadays, okay, you got a fuel cell, you want to use it, or you got an electrolyzer. And now you want to bring this product into serial production, and now you got issues that you, for example, taking a glue, which takes about 60 seconds for curing. But you have to be aware that we do require cycle times in the near future, 1 part a second. So it means we need 60 stations to do this. And this is not a good idea in regard of costs.
Let me ask a quick question for all those who are not so familiar with the fuel cell production process. So when you're talking about gluing, for example, you mean the stacking of the bipolar plates with gaskets, or like which manufacturing step are you referring to right now?
Yeah, exactly. It's first of all, when we talk about gluing, for example, it's about the mere production mostly. What comes along in the same way is sealing. Sealing materials are as well a very important part of a fuel cell or electrolyzer, because the material has a lot of stress during the use of a fuel cell or electrolyzer.
Gotcha.
And we have still to choose what's the right material.
Okay.
And there's so many differences from them which you could take into consideration, and each of it requires a different way to apply it and to cure it. And so we have to find the right process for the right material.
Okay.
And this is a lot of things which are still open here, which are not solved yet.
Is it that you address this by means of simulation and analysis, analytically, or can you just do it by trial and error kind of?
It's a more holistic view on that story. What we have to look into is what is the requirement of the customer. Does he has already a solution? If not, we take the chance and provide him some suppliers we know, and to go for trials with the supplier to choose the right material.
Okay.
In parallel, we are looking to find the right solution to apply the sealing material on the bipolar plates, in the electrolyzer, wherever it's required.
Yeah, maybe we can give a little overview of what is all we needed.
This is an overview what our company does in regard of assembly and testing technology.
Yes.
And we're talking about the fuel cell production and the electrolyzer production, which is going along with single step of the mere production, bipolar plate production, stack and system assembly and testing. With the gluing, for example, it's more within the mere production. You have to glue together some foil material, and therefore you have to choose the right way of gluing.
Yeah.
And the sealing is to seal the space between bipolar plates and the mere. Sometimes you apply the sealing material on the mere, sometimes on the bipolar plate, depending on the design of your specific system.
Yeah.
Second of all, what is getting very important in parallel, I any time point on the design consulting, process consulting now.
Okay.
We have to step into that because it's not just you want to provide a rope of a sealing on the surface. You have to look to the design of the bipolar plate, if this is designed in a way you can apply it in the right way, for example. Yeah.
So it's designed for manufacturing.
Exactly. And once this was done, you have now the idea how you can make it. Now you step into the process. You put it into the sequence.
So maybe we should highlight here why it's such a crucial element on getting the adhesion and the sealing of all those MEAs and bipolar plates right. because it's kind of a serious connection of faults that can occur, right? If I have to get every part of that stack correct in order to have a functional stack.
Nowadays, existing solutions are not designed in a way to take easily over to manufacture fuel cells or electrolyzers.
Right,
exactly.
right.
And therefore we have to develop such new ways of applying the materials on the surface of the plates or the mirror. And second of all, you mentioned already before, we need a quality check to be sure that any plate, any cell is fine before putting it into the stack.
Yeah, to give a feeling about how many stacks are we talking about, how many plates are we talking about in a general stack, to have an idea of, okay, how many parts in series have to be correct in order to make a functional stack.
Yeah, exactly. So in normal we are talking about 300 to 400 cells in a stack of a common stack, which is going along with roughly 100 kilowatts, for example. And now you got 2 ceilings per cell. This means you got 800 ceilings you have to look into.
Are you there that you can say that you already are able to inline test and validate during the assembly of the plates?
We are working on multiple solutions. We are looking at the very beginning to have camera systems who are able to make a camera shot in less than a second and to measure anything if this was according to specifications.
Okay, gotcha.
And this is a huge challenge because nowadays camera systems are simply too slow to follow up such high speeds.
What's the frame rate that is needed in order to...
Maybe I have to face, we're talking about 3D measuring of the ceiling. That's the point.
Gotcha.
And so you got much more data in a very high resolution.
So looking in the Z-axis as well.
Exactly.
When will a stack be manufactured with a guarantee that you don't have the scrap rate higher than, and you name now the number? So where's the scrap rate right now, and where do you want to get it?
So my concern is not the stacking. This is working with a good quality already, and we are nearby the 1 second per piece production. That's working,
1 second
and
per piece?
even faster. We have a running R&D project which is founded to go any faster. The processes before you put the single parts into the stacking system, there we need some improvements to be done. For example, bipolar plate production.
So you're saying the stacking is more or less solved?
Yes.
In terms of quality assurance?
Yes.
But it's about merging the production of all parts so that they match in the end.
Exactly,
right?
that's a challenge.
Every part in itself has a tolerance, and if I exceed the one part to the left by 1 millimeter and the other to the right by 1 millimeter, I have 2 millimeters, and I'm just exaggerating here. But that is the issue that you're facing in fuel cell production at the moment, right?
Exactly. The pre-products you put into the stack have to be accordingly to the quality, otherwise you will never reach the quality you are aiming with the stacking.
So how mature is the process on leveraging the quality to the needed requirements?
So on a lower speed, in specific talking about the quality check, we are already able to provide sufficient systems with the right quality. Our challenge is here to look for the 1 second cycle, which is going along with the 50,000 stack production per year, which is a target for most of the companies by the end of the decade to be able to manufacture 50,000 stacks on a line. And if you make the numbers and you put them down, you will figure out you have to manufacture 1 cell per second or 1 bipolar plate or mirror per second. That's a challenge to speed up those tests in the required speed.
Okay, so challenges ahead, but a big potential as well.
Thank you very much. Nice being here and talking to you.
Thank you.